Section 2.5, Transformations of Functions. Before we can talk about transformations, we need to be able to know and identify easily some basic functions. So first we have a linear function. That's just a straight line. You should be familiar with those. Power functions, x to an exponent, x squared, x to the third, x to the fourth, and x to the fifth. The root functions, square root, cube root, the fourth root and fifth root. A reciprocal function, 1 over x, 1 over x squared. The absolute value function, and the greatest integer function. So for a basic function, f of x, there are many ways you can shift it, or reflect, or even a stretch. First, if you just add a c on at the back of the equation, it would shift up c units. So for example, if we looked at the square root function, square root of x plus 3 added on at the back would shift that up 3 units. Subtracting would shift it down. Very similar. Subtract 2 at the back, it would shift it down 2 units. If you subtract inside parentheses or grouped with the x, that'll make it a horizontal shift. And it's opposite. So negative or a minus would actually shift to the right, and a positive added on to the x shifts it to the left. So if you subtract 4 and it's grouped with the absolute or the square root, subtracting 4 shifts it right 4. Here we're adding 1 grouped with the square root, so it is shifting left 1 unit. A negative out in front would reflect it over the x-axis. So a negative in front of the square root would flip that over the x-axis. A negative inside right in front of the x would flip it over the y-axis, reflect it over the y-axis. You can also multiply by a number. If you multiply by a number all the way out in front, if that number is greater than 1, it will vertically stretch it, make it taller, by a factor of whatever that number was. So 2 out in front of a square root would make that be taller by a factor of 2, stretch it vertically by a factor of 2. If that number out in front is between 0 and 1, like a fraction, it will shrink it by the factor of whatever fraction that is. So a 1/2 out in front would shrink it vertically, make it shorter by a factor of 1/2. If you multiply right on with the x, if it's greater than 1, again, it's backwards anytime it's with the x. Multiply by something bigger than 1, it will actually shrink it by a factor of 1 over a. So this 2 in front of the x inside the square root actually does a horizontal shrink, makes it skinnier by a factor of 1 over 2, 1/2. And again, if that's a fraction, then it will stretch it by a factor of 1 over a. So 1/2 in front of the x inside the square root will actually stretch it by a factor of 1 over 2, which would just be 2. It would stretch it by a factor of 2. So let's look at an example with some vertical shifts. We know x squared is a parabola. X squared looks something like that. So this is going to shift it up 3 units because we're adding 3 on the back. So that shifts up 3. So if the normal graph would be a parabola that goes through the origin, this will now be shifted up 3 units. And now the vertex is at 3. Similarly, subtracting 2 at the back, that's going to shift it down 2. So a quick sketch, rather than being at the origin, it's now going to shift down 2. So now the vertex will be down here at -2. And the parabola would look something like that. Sketch the graph of each function. X cubed minus 9x. You can type that into your calculator to see what that graph looks like. And here's the graph of x cubed minus 9x. So if you look at part B, x cubed minus 9x plus 10, it's the same function, they're just adding 10 on to the back. So that should shift up 10 units. So my window on my calculator is set to x goes to -10 and +10, y goes from -30 to +30, so we can get a good viewing window. Now, the graph of part B, I'll go ahead and sketch it right here with part A still. And should be shifted up 10 units. Right there. Part C, again, that's the same function, but now it's -20. So that should shift it down 20 units. So now I'll tell my calculator to draw that function as well. It's going to keep all 3 of them on here now. But now it's going to draw the new one down below. And you can see that it shifted down about 20. For some horizontal shifts, we can see the basic function here is x squared, which, again, that's a parabola. We know that looks something like that. So x plus 4 squared, that's going to shift 4 units. Remember, it's opposite, so that's going to be 4 units to the left. So a quick sketch of that. 4 units to the left. That's going to be our vertex now instead of the origin. So the parabola would look something like that. Now g of x equals x minus 2 squared. That's going to shift to the right 2 units. Remember, it's opposite. Minus means to the right for horizontal shifts. So quick sketch, it's going to shift right 2, so instead of the origin being 0, 0, the vertex is now shifted to the right 2 units, and then we have our basic parabola. Here's an example where we combine horizontal and vertical shifts at the same time. The basic function here is square root, which looks like that graph. But we have x minus 3 inside and then plus 4. So this plus 4 is going to shift up 4 units. And this minus 3 in the square root is going to shift to the right 3. So instead of starting at the origin, this graph is going to start up 4 units and to the right 3 units. So it's going to start at this point, 3, 4, instead of the origin, and then have the same look like that. Now for some reflecting, f of x equals negative x squared. We know, again, this is a parabola. It's going to look something like that. The negative in front is a reflection over the x-axis, so it's going to flip down. There's no shifts involved in this one. It's just going to flip down. So the origin is still 0, 0. But now instead of being a parabola going up, it's now a parabola going down. And then square root of negative x. We know square root has a look like that, but the negative in front of the x is going to reflect it over the y-axis. So the origin is still going to be, or the starting point is going to be the origin, 0, 0. But now instead of going to the right, it's reflected over the y-axis, so it's going to look the same way, but going to the left now.